In this video, I'm going to break down how to use AI into 4 main pillars. By the end of the video, I promise you that you will feel confident when it comes to how to start using AI, what's possible with AI and modern technology, and lastly, regardless of what's to come, that's new tools, new updates to large language models, you can feel confident that you are using the technology in a way that will set yourself up for success in the future, regardless of what domain you're in. The 4 main pillars I will be covering today are the different types of solutions. That is the different ways you can build software to make yourself or your team more efficient. Next will be some key components that are features that can be used within the software to increase the functionality and enhance the outputs of these given solutions. Third, we'll talk about the term smart and what that means exactly, but also how that applies in a more practical sense. And lastly, we'll talk about the 80-20 rule, in other words, the Pareto principle, and how you can utilize this to ensure that no matter what tool, what LLM you're using now or in the future, you are always setting yourself or your team up for success. With all that being said, let's get into the first pillar, and that's different types of solutions. A solution for me is just some sort of technology or software that makes you more efficient, thus solving your problems. And solutions are, you can go very in depth with solutions, but I like to simplify it into these 3 buckets. And to start, we'll talk about just generic workflows. So what is a workflow? A workflow is essentially a process that never varies and always follows the exact step-by-step process every single time, right? So from decision point to the output point, the process in between will always be the same, but the input may be different and the output may be different. But the process to get from the input to the output will always be the same. So the key takeaway here is no variation in the process. It is the same exact process, step-by-step process every single time. Secondly, we have AI workflows. Now, an AI workflow is very similar to a generic workflow, but now you just have within that step-by-step process, you have a model making a decision or executing a task along the way. However, the model will always be executing the exact same task. So I actually have this from trying to film this section earlier, but let's say here we do not have an AI model. Let's say we just have a generic step. Step 4, right? It's the same step-by-step process from the input point to the output point. However, now you have a model executing an explicit task or making an explicit decision every single time. Now, what I had before, right? Let's say we have 2. We have 3 AI decision points or execution points. This is still an AI workflow because the process from the input to the output will always be the same, even though there's a model deciding there could be different paths and different outputs. The actual process is the same, and these models are making the exact same decision or executing the exact same task every time. So to sum this one up, it's no variation in the process. However, you have an AI decision / task execution point, right? And then I would say you can have multiple, right? But the biggest takeaway is that no variation. There's AI decision or task execution point, and you could have multiple, but that explicit point will always be the exact same decision or task that it is executing. No variation in task. I'm just going to say in execution. All right. So lastly, I like to call this AI ecosystems, but it's most commonly known as AI agents or agentic workflows. And to sum this up very fast, all it is now you have an AI that's an extreme variation. I really don't like how it's typing this out. Extreme variation. I just say AI is determining the process. So now in these two, there's no variation in the actual step-by-step process. In this, and you may have AI within that step-by-step process, but now when you have agents or agentic workflows, or what I like to call it ecosystems, now you actually have the model determining the process from the input to the output, which means that there is always going to be, or not always, but there is going to be some sort of variation from the input point to the output point. And what I have here are tools. Tools are essentially just one of these steps, right? So it could call various steps based off of its own. It's deciding which steps to call in order to get to the output. But where this gets really powerful is now, let's say we have this same AI, right? But when these systems get extremely powerful is when you interweave all of these three buckets together, hence the ecosystem. So now you could have, let's say you have a model. Let's say this same agent here is calling this, can call this guy, and this model can call the actual agent itself, right? Plus has explicit tools and steps that it can call as well outside of this actual agent. And it could also call generic workflows as well. So now, as you can see, this is extreme variation in the process, but it also means that this model can do a lot more than just a simple workflow or a simple task or determine a simple process. It can really grow exponentially, and that's when things get a little bit complicated, because you're not only depending on a simple workflow, right? You're now depending on the software. Every line of code that goes into this explicit workflow, you're depending on the line of code that goes into this, these explicit tools, plus the actual, no input here. They wouldn't have any input, right? The explicit tools that have, the code within these tools and the API calls, plus the actual workflows and the prompting that goes into the decision points within those workflows, and the agents prompting to call those workflows, plus the orchestrator's agent to orchestrate the whole thing, right? Like, it gets really complicated really fast, but I hope you can get the picture. And what we like to do with our clients is, if they don't have any kind of infrastructure or solution, or have any solutions in place, we'll start them here. Then we'll move to here. Then we'll eventually, with the goal of eventually getting to this point. So the next pillar are just some key components that I think are really important when it comes to utilizing AI. So first are tools. So I kind of got into it in the first pillar, but a tool is essentially just a single step, right? And this could be anything like, let's say, a single step within a process. And let's say a tool could be like a simple API call, right? It can be, I don't know, it can be an HTTP request, right? It can be anything you really want, right? It's just a single step within that process that can be called by a model at any time. And when you get the term, when you think about MCPs, which is another hot term, they're very powerful. Essentially what an MCP is, now you have a suite of tools right? So now we have a suite of tools that the model can call, but instead of calling the explicit tools on their own, it could call the MCP, which handles the kind of best practices or the best approach on how to sequentially call the tools accordingly. And that's when you get the term, when you get the idea of like AI talking to AI. Anyways, so next is memory. And what a memory does is it essentially is just going to remember, especially in the case of the AI agent, it's going to remember the explicit process it took to go from the input point to the output point. And that memory allows it to, train itself over time. But memory could also apply to communications or customer handling or talking to an individual. So a memory can, I'm Claude, I'm pretty sure, I know Claude has like a memory base within like a project file, but I'm not sure about ChatGPT. I think Gemini has a memory base, and that's what it can do is remember past conversations for additional context. And I'll get into this in the next step, but context is such an important piece of the puzzle. And this is another way to add context. So a knowledge or database. And now what memory is, memory kind of falls into this category and they're kind of correlated, but a knowledge base or a database is just a ton of context, right? That is being stored. That a model can either store information into or pull information from. And this context could be anything like data, documents, PDFs, images, whatnot. But it's storing the context, which is the information, so that it can retrieve it later. And that's where we get the term RAG, which is retrieval augmented generation. And all that's basically saying is an AI can pull information from a database or a knowledge base to answer a question using that context for the actual output. And so if we go back to this massive ecosystem, where is it? It could have here, you could have an actual database, which when people hear database, they get nervous. It's literally just like an Excel sheet. It's just a mode of storing information, and there's so many different kinds, as you can imagine, for images, for whatever. But you can think of it as like a Google Drive plus like Excel sheets, and you're storing them accordingly. But you can have a database, and this could be your source of context, right? So I could tell a model to not only to execute a task and provide me the metrics on how to get that on, provide me a finished product for, let's say I'm applying for a quote. I want you to apply for a quote or come up with a quote based off of this information, based off of this job. And it let's say you have all the unit material costs within the database. And in order to get the quote or the proper format for the quote, it needs to execute this workflow. And then, it gets the information from the database, then executes this workflow to come up with the process. And then maybe this workflow verifies the quote. using other tools like, searches the web for relevant quotes, etc. But the database is just that context of information that the model can pull from to enhance and increase the quality of the output. So next is vector databases. And essentially, now that we have the database, this is the term vector is just AI's way of storing it. So when we think of a database, like I referenced like Excel or Google Sheets, it's stored in that neat table format, or Google Drive, you have folders, etc., right? But for a model, it needs to have some sort of mathematical, sequence or coordinates on how to pull that information. How it does that is legit putting mathematical coordinates on every single row so that it can pull the information according to the sentiment of the request, right? And this is the easiest way to understand what these coordinates are. So they're called embeddings. And in order for an embeddings or a vector database for an embeddings to be retrieved from, they need to be stored by an embeddings model. And these models put those coordinates within the database for each row and for each input to allow the actual model to call that embeddings, right? And I'm not going to get into that right now, but the way I think about embeddings is you have a house, and let's say your database is the house, right? Let's say your database is the house. And here you have the kitchen, maybe not on the highest floor, but you have the kitchen, you have the bathroom, you have the bedroom upstairs, right? And let's say you have each room. Let's make it a nice little room, right? Kitchen, it's not spelled right. Right? You have each room, living. Let's make a fourth room to make it look nice. Living, thing. All right. So you have your 4 rooms. Essentially, what a vector database or an embeddings model will do, let's say embeddings model. Let's say you are the embeddings model is you just went grocery shopping and you're trying to store stuff within the house. You're putting stuff away. So if you have a toothbrush, let's say you bought a toothbrush, you're going to store it in the bathroom, right? Because it makes sense. Unless you're, that's the bedroom. Let's say it's going to be in the bathroom, right? Unless you're doing something weird with your toothbrushes. Anyways, so you would store that in the toothbrush, right? You'd store that in the bathroom. Now for a bedroom, let's say you bought bed sheets, right? You would store that in your bedroom and put it on your bed, right? Same thing with the kitchen. Let's say you bought a new pan. I think you're getting the picture here, right? So each one of these inputs can be anything like a number, a chunk of text. Regardless, what the embeddings model is doing is essentially storing a coordinate. So now let's say this is where you put that's going to be your bed sheet, right? That's your bed sheet right here. Right, that little circle. And the model will create coordinates here according to the sentiment of that input in relative to the higher concept. So let's say now I ask, after you've stored all the stuff away, hey honey, like where did you put, like, did you put the bed, where are the bed sheets? Where are the fresh bed sheets? Or where is the toothbrush that you bought me? You would then be able to think about, okay, it's in the bathroom and it's over here because we keep our toothbrushes here. That's essentially what the embeddings model is doing. It is storing it from a mathematically conceptual standpoint into or just organizing the database accordingly so that when the model gets asked, what is the What is a bylaw that goes into building a pool? It knows to search the bylaws for that given location, for that given city, and the document to search because of these coordinates. So it's basically a vector database is an organized database with locations, so the model can go in and like retrieve the information quickly and intuitively. So lastly is the concept of human in the loop. And this is arguably one of the most important and slept on features of software and AI solutions, right? People think nowadays, because of all the discrepancy between what people understand about AI and what's possible, people who don't understand are hearing about what's possible and it's scaring the heck out of them. So when someone doesn't even know what a workflow is and what's the capability of a workflow, they're hearing about agents, right? Let's say a business owner's pen to paper, and they're hearing about AI agents that are automating the entire, project management process, or, accounting process, or financing process, or sales process. And it's like, that's kind of like concerning to hear about, right? Because you don't have any control. That's, you don't want to just hand the keys to, technology to essentially just do your job for you. But the important thing about, or what the human in the loop essentially does is it allows you now to be a part of that process. So let's say at this point, you have a model coming in here, right? So let's say this workflow, this is you. So you get their input, you decide, it goes step 1, step 2, AI comes with an output, and then it goes to a human to determine whether it should, it's good to go, right? Or whether it's not good to go. And what that allows you to do is that allows you to basically handle and ensure that the output meets your criteria. So now if you think about it here in this sense, you could have this crazy model, right? And you could have it do all this stuff. But at the end of the day, if you wanted it to, you could have it run it by you. You could have it do all this crazy stuff. And then before it actually gets sent or delivered or finalized, right? You could have it come to a human, yourself, an employee, whatever, and you could you can confirm whether it is ready to kind of be finalized or whether it needs a review. And it can be sent back to the model, or you could just decline it and stop the workflow as like a way to ensure that nothing sensitive is going through. And there's so many different examples, but the idea is that you can have all this stuff going on, but at the end of the day, a human in the loop allows you to come in at the end of that process and determine whether the actual output is at par with your standards and you're okay with that output, right? So let's say if you have in customer communications or customer handling, right? If you're afraid of a model, interacting with your customers and saying something bad, you could have a human in the loop that, let's say you're emailing back a customer, instead of having the model actually send that email, you could have it create the draft and send you a message letting you know that the draft is created. And then you would just come in and review the draft and press send, right? And then another feature is, you could actually have a model here. So let's say you're the human in the loop, right? And before the output, you have another model, right? And let's say you determine whether it's ready. Let's keep it like that. Let's say you determine whether it's ready to go or not. And where it gets really cool is you can then have another AI here making a decision. So an example of this would be, let's say in that same email example, you're having a model respond to a customer, request, right, or concern. And it creates the draft and it tells you, we created the draft, or it sends you it via email. And you can then you can have like two buttons that says yes or no. Or you can, give it a response and say, this is not ready because X, Y, and Z, or change your tone. And then you could have a model actually make that fix, right? Until it gets back to you and you approve. And only when you approve, the output the output or the final outcome occurs. Very powerful stuff. So lastly is the third pillar is the idea of smart. And this largely has to do with context. So if I were to take this workflow here, right, where the term smart comes into play is the ability for a model to improve over time based off of its past, decisions or task execution, right? And how this is done is in a few different ways. So like I said before, I touched on it a little bit, but when you have like a memory, right? And let's say going back to that customer communication, right? If you have a model and it's handling some sort of message from a client or a customer, right? This is your input. Output, right? And let's say 5 months ago when the client sent a message, they said they love cheeseburgers, or let's say cheeseburgers are my favorite, right? I'm hungry. Boy. Let's say cheeseburgers are my favorite. They said that in an interaction a long time ago. What a memory allows it to do is it allows the model to store that conversation. And in future, communications with that particular client, it may remember, let's say the client asks, where should I go and eat? The model will remember that she said cheeseburgers are her favorite, and then it'll recommend her 5 burger spots, Five Guys, McDonald's, ATC, right? You get the picture. It's essentially remembering from the past. And this is especially powerful when you have some sort of like customer handling system or a model interacting with customers, because it can remember that explicit conversation and keep a context window and have the context on the communications with a customer that they had in the past. So the second element of the idea of smart is where machine learning comes into play. And this is, again, how things get very powerful. So intertwining this with a human in the loop process, right? Let's say we're doing this same thing with like the emailing, right? I'm sending the model's coming up with an email response to a customer. Me, the executive, is coming in and saying, I like that, or change this. And it keeps doing this until the output is finalized, right? I'm not going to do the thing right now. It keeps doing it. It keeps making the changes until you confirm that the response is ready to go, right? So where the last leg of training comes into play is, let's say after a month, that's machine learning. That is really small. Okay. So let's say after 5,000 emails, when it first started this model, it had no context in terms of it had no idea about how you like to respond to emails outside of its prompt. If it had a phenomenal prompt that explicitly tells it exactly and provides it all the context on how you like to handle your customers, that's awesome. But most cases, and when you get into solutions where they're solving, and you have a model solving or, coming up with a solution for, or making a decision on something that requires a ton of information that's based off of a ton of information, like, some sort of industry expertise or industry insight that it just does not have access to and cannot fit in a prompt. What it can do now is essentially, based off of its first initial run, so that first email it sends you, right? Let's say this is the first customer relationship or first customer response this model's handling. It goes to you, right? You say no. Okay, retries it. Goes to you, it says no, retries it. You finally say yes, it goes to the customer. So now let's say that this process is happening 5,000 times. At first, let's say this is error. What you wanted, right? Let's say first time it ran through you had to tell it what to do 3 different times, right? And let's say after let's say over time, let's say this is, for the sake of the example, let's say this is like, you had to tell it what to do 6 times, right? Or 10 times, right? The point is the margin of error was large, right? And you had to keep telling it what to do. The idea is over time, it'll analyze the original output plus your inputs, your finalized product, to eventually narrow that gap, right? So that after 500 or 5,000 email drafts, the error is going to be practically none. And why this model or this framework is the best is because, so you can have something where it doesn't have this, right? It doesn't have this model making the adjustments. But the reason why it's the best is because you get to now see and identify, the model gets to learn and identify on every single tweak that you make. It's just more context. The main point of this is you're training a model on the context of the original output versus what you're looking for. And then eventually it's learning how to narrow that gap. And it's the same thing with the memory. It's just storing information for additional context to be able to perform a task more optimally in the future. Same thing with the vector database. It's just context. It has a ton of information and can pull from that information to provide it as context in regards to your request and giving you a higher quality response. So that's kind of like the gist of the term smart is these models are getting and are training themselves over time to increase the margin of error and enhance the quality of output. The last thing I'll say on this is this gets really cool is now you have this model here. Let's duplicate this, right? You have this model here and you're now seeing, you can then have it train itself on the process, right? And over time, it's going to be able to identify through its memory and with machine learning, the most efficient way to call on these processes and tools, right? And how to optimize the time from input to output, the process from input point to output point. And as you can see, it's pretty powerful. And as you can imagine, it gets very powerful. But like I said before, it's like puzzle pieces. You have all these little puzzle pieces that you can plug and play with and utilize to create and eventually get to a fully autonomous system. And that's what you see with, Salesforce, eliminating 40% of their, customer handling employees and optimizing and scaling and, increasing their EBITDA by like over 130%, something crazy. Like, this is what they're doing. And the point is you need to start now and eventually to get to, the idea of like this massive ecosystem with orchestrator, models and agentic workflows, because this takes a lot of time and there's no real one-time fix. The benefit of these solutions is that they're backed by large amounts of context. You have context in the memory, you have context in the database, you have context with every tool run to remember how that pertains in terms of efficiency towards input to output. And it's just tracking all that information to allow the model to make better informed decisions going forward. So the last pillar that I wanted to talk about, and I think this is the most important, is the 80-20 rule, Pareto principle. And I firmly believe that this is going to be the difference between, if followed properly, this will be the difference between those who win in the era of AI versus those who fall behind or lose. So what this is getting at is essentially what all of the stuff I just talked about does. What all of this stuff does is it should never completely replace what it is that you do. You're the expert. You're the one with the industry insight. You are the final decision maker. What these systems should be built to do is let you be the executive of yourself or your job. And what that means is, think about an executive at any big firm, right? They do the first 10%, they make a decision, they determine the best approach, right? The process, they determine the process or what they want. And then they send it down the chain, right? And then it goes all the way to the bottom of the chain, and then it comes all the way back up. And that same executive makes the final decision, right? He may decide that it needs more work, goes back down the chain, comes all the way back up, right? But the point is that executive is able to manage an entire firm of hundreds of thousands or hundreds to thousands, whatever, of employees, because they're only doing the first 10% and the last 10%, right? And if you look at this crazy model that we had built, right? This is exactly what you're doing. You shouldn't have a model that completely finishes or does, that completely handles customer interactions or completely handles your finances. But what you should do is you should have a system and work towards building a system that allows you to do the first 10%, determine what process or what to do, right? Have the model execute that process while, potentially even learning over time, right? Let's get the laser pointed out. So you're doing the first 10%, you're deciding and giving the model the inputs. That could be telling right now as an executive, that could be giving your employees the sales deck or the elements that go into a sales deck and what you want it to look like. And then it goes down the chain, right? Then that goes down the chain. Then that goes down the chain, right? And then that gets stored. People remember, right? That employee did a good job. That employee did a good job down here. So we're going to remember that in the database, right? And then it comes all the way up the chain, right? Goes down the chain, comes up the chain, right? And then it comes right back to you. And that's where you're doing that final 10%. And you're finalizing and proving it. And if you don't like it, it goes all the way back. And it does the exact same thing, does all the work. That way, over time, no matter what AI is able to do, even if AI is able to, take over your entire workforce or your entire team, imagine how much more efficient and how much of a game changer this is if you have a team of 5 employees and you're looking to hire 15, 20 more employees to edit PowerPoints and handle customer communications, instead of, for a fraction of the cost, building something like this or running something like this and having those 5 employees be the executives of their own role, right? That's the potential, and that's how you can assure as a business owner or especially as an individual that you are using whatever technology that is available in the most efficient and appropriate way that will guarantee that you are successful in the future. And this is where critical thinking comes into place. You're able to determine the most important parts of a process and have the model and AI do all the rest and the grunt work. Right? You come up with the idea for a paper, right? As a student, you're not going to have the model like give me the topic for my paper and write me all the quotes. No, you're going to come up with the topic, give it the quotes, right? And then have it write the paper and build it in like 5-10 minutes, not or 5-10, like 1 to 2 minutes. And then it comes right back to you and you do the final proofing and determine whether it is ready to submit or it needs more work. And then you need to determine and tell it what else it needs to do. But the point is what's happening now, and with technology and where it's going, no one knows what it's going to be able to do. But if you're not someone who understands how to utilize these models and understands and does not, I guess, use AI and modern tech following this kind of approach or principle, you're going to lose and completely, I guess, never use your ability to critical think and grow in terms of your ability to think critically, right? And if you're someone who feels like you're in this process, the way to get ahead is to start utilizing a workflow, a simple AI workflow, and understand how to use them in order to do what you do more efficiently and accomplish more. So no matter what happens, if Gemini 10.5 is out and it's able to, make you breakfast, right? You still need to determine what kind of breakfast you like and if it toasted the bread for long enough, right? That's how you stay ahead of AI, and that's how you should be thinking about the different tools that you use going forward, the different models. You should never be supplementing this 20%. It should always be you, and you should let the model do the middle grunt work while you focus on the 10 and the 10. That's how you get to do 10 times more than what you're currently capable of doing, and prepare yourself for the shift in the labor force that's bound to happen and destined to happen. Anyways, so that's the end of the video. To sum things up, we went over the different types of solutions, simple workflows, no process, no variation in the process, same step-by-step, no decision-making. AI workflows, same step-by-step process, no variation, AI decision point or points. But those decision points involve one decision that's being made or task that is being executed, and it's always the same one being executed every single time for every model. And then you get into the ecosystems where you have agents, models calling on models with tools and workflows and AI workflows all integrated together to really kind of start, executing and doing some crazy stuff. In terms of key components, we went over tools. They're just like a simple step, one of these steps in the process that can be called by a model. An MCP is just a suite of tools and a model that's able to, streamlines the tool calling process and the density of a prompt. Memory is essentially just a model storing context. It's a mode of context. All three of these are mode of context, but a vector database is how a model actually stores information intuitively in mathematical coordinates in order to optimize the retrieval process, which is grabbing the information and being able to come up with an output. And then human in the loop is revolutionary, especially for business owners that are afraid to adopt AI, because at the end of the day, what you could do is you can have all this crazy stuff, right? You can have like 10 of these, but when push comes to shove, before that email gets sent or before the report is created or before the final outcome is achieved, you put yourself here, which then moves into the final kind of principle that I laid out, which is the 80-20 rule, where you are doing the 10% and the first 10% and the last 10% AI and modern tech should be focused on getting that 80% done for you. That's how you ensure that you're a winner in the next 10 years to come. Thank you for listening, and check out the rest of my page. I have a ton of other videos that I'll be posting about, showcasing how I build these workflows, AI workflows. How do I determine which is the best kind of type of solution to build given a specific bottleneck in my day-to-day. And I also just share cool tips and insights that I find helpful for me. Again, I don't have a background in software tech. I'm self-taught and self-learned over the past couple of years. And if there's anything else that I missed in this video that you'd want me to cover and try and simplify, please leave it in the comments. And if you made it this far, thanks for watching. And I hope this was helpful. See you in the next one.